Hello, I'm David Mahler, and this is an introduction to Git branching and merging. In this video, we will set up a new Git repo, define Git branches, create, work on, and delete branches, understand the purpose of the head pointer and the meaning of a detached head, merge branches using both fast-forward and three-way merges, create and resolve a merge conflict, work with Git stash to avoid some problems with checkouts and merges. As a prerequisite to this video, I recommend my Introduction to Git Core Topics video. This video assumes knowledge of the foundational information covered there. Those topics include the Git commit graph, working tree, and the staging area. I will link to that video in this video's description. References. The only reference for this video is the Pro Git book by Scott Chacon, which is a fantastic resource for diving in. Now let's jump right in with a new repo. Start a new Git repo. As with my video on Git core topics, this video will be a fake network automation project. However, the specific content of the files is not relevant for our understanding. We simply need some text files to use with version control. Let's make a new directory on our file system named netauto. We will move into that directory. From here, we will create a repo with the git init command. Now let's add a file to our repo named s1. I'll paste in some YAML data for a network switch and save this. Let's get this file staged and into our first commit. We stage s1 with git add s1. We commit s1 with git commit -m create s1. Now we have our first commit. Let's make one more commit so that our git history is longer. We can add a file s2. I'll just copy s1. To stage our new file, we run git add s2. To commit this, we run git commit -m create s2. With git log, we see our two commits. Let's run git status. Git tells us we are on the master branch. We didn't create this branch, Git did it automatically on our new repo. Git also gave the first branch the name master. Git branches. What is a branch for? Branches allow us to work on different versions of the same files in parallel. Our edits on one branch can be independent of work on other branches. We can then decide to incorporate or merge our changes into other branches. Branches result in a separation of versions of the same files. In this way, we can have branches for different purposes. For example, we could have a production branch, a development branch, and a branch to work on bug fixes. How is a branch implemented? The implementation of a branch is actually quite simple. Let's look at our commit graph to see a visual representation of a branch. Here is our new repo with its two commits. Every commit has a 40 hexadecimal SHA-1 hash. The first 7 characters of those hashes are shown here. By default, Git created our first branch, the master branch. A branch is just a pointer to a SHA-1 hash. Right now, the master branch points to our second commit. As long as we are on the master branch, every time we make a commit, the branch moves up to our latest commit. It follows along, staying at the tip of our line of work. The way Git knows which branch we are on is a special pointer called head. Head. Head is a pointer that normally points to a branch. So far, we only have the first branch, the master branch. Therefore, head is pointing to that. Since head usually points to a branch and not directly to a commit, it is sometimes called a symbolic pointer. In Git terminology, the head pointer tells us what we have checked out. So right now, we know we have the master branch checked out. Let's look at our branch and head from the CLI. Git log shows our commit history. With some options, Git log can also show us a nice labeled commit graph. Git log with the options all, decorate, one line, and graph. When we run this, we see the commit graph. We see that we are on the second commit due to the head pointer. The head pointer is pointing to the master branch. This tells us we have the master branch checked out. This set of options for Git log will be useful to us in this video. Therefore, I'll create a reusable command alias. With this command alias, we can just type graph to see this commit graph output. So we have our first branch master that Git created for us. Let's create 2 more branches to work with. Create new branches. We make new branches with the get branch command. The branches will be instantiated where the head pointer is. We will start a branch named SDN and another called auth. Back to the shell. Get branch SDN. That makes a branch named SDN. Get branch auth. That makes a branch called auth. The get branch command on its own shows us all of our branches. We now have 3 branches. There is an asterisk next to the master branch and it is green. This tells us we have the master branch checked out. More precisely, the head pointer is pointing to the master branch. We can run our new alias command graph. We see our 3 branches all pointing to the same commit. We see head is attached to master since we have master checked out. Let's work on our new branches. Check out and work on branches. We have our 3 branches, master, SDN, and auth. In a moment at the CLI, we will check out the SDN branch with the get checkout SDN command. When we check out the SDN branch, the head pointer will move to point to the SDN branch. While we are on that branch, we will edit our file S1. We will stage and commit that change. Since we have the SDN branch checked out, only the SDN branch will move up to the new commit. The master and auth branches will stay where they are at the previous commit. After that, we will work on the auth branch. We will run get checkout auth. That will move the head pointer from SDN to auth. While on the auth branch, we will make a different change. We will stage and commit that change. This will create a new commit, and only the auth branch will move to it. We will end up with our 3 branches pointing to different commits. The content of our file S1 will be different depending on which branch we check out. Let's do all of this now. Graph shows us head is pointing to master. We have master checked out. Get checkout SDN moves us to the SDN branch. Now, graph shows head has moved. It now points to SDN. Get status also shows the same, on branch SDN. Let's edit S1 to add an SDN controller IP. Let's commit this change. Git add S1 to have this staged and git commit to make our commit. Graph shows our updated commit graph. We see our SDN branch has moved to reference our newest commit and head stays with it. Our 2 other branches, master and auth, have not changed. They are still back at the previous commit. If we run cat S1, we see the newest change. The SDN controller IP is there. Now let's check out the auth branch. Git checkout auth. Git checkout auth moves us to the auth branch. Git branch confirms this. With graph, we see how the checkout command moved the head pointer. Head has left SDN and is now attached to auth. Cat S1 reveals our SDN controller line is now gone. Git replaced our working tree and our staging area to match the commit auth is associated with. At this earlier commit, we don't have the SDN controller change. To see that again, let's check out the SDN branch again. Git checkout SDN. Cat S1 reveals we have that SDN controller IP back. Git updated our working tree and our index again to reflect this commit where we made the change. Back to the auth branch. On the auth branch, we will map our S1 switch to an authentication server. We will save that and exit. Git status shows us that we've modified S1 in the working tree. Now we can use a shortcut to both stage and commit this change. The -A option will stage and commit any tracked files that have been modified. The graph command looks similar to the commit graph diagram we looked at earlier. We started at this commit here. Master is still pointing here. From this base, we branched out in 2 different directions. We checked out the SDN branch and added an SDN controller IP. Then we checked out the auth branch and added an authentication server IP. Now let's say our work is done on the SDN and auth branches. We want to integrate these changes back into the master branch. In other words, we want to merge our new changes into master. We will talk about two types of merges, a fast-forward merge and a three-way merge. First, the fast-forward merge. Fast-forward merge. We decide we want to get the SDN controller config into our master branch. The commit where we added the SDN controller is here. The SDN branch is pointing to it. This commit's parent is here. This is where the master branch is. To merge SDN into master, we use the git merge command. Since there is a direct path from master to SDN, Git can perform what's called a fast-forward merge. The fast-forward merge means Git will just move the master branch to where SDN is. Master just has to catch up with SDN. Even if there were multiple commits between the two branches, there is still a fast-forward merge. We just need a direct path. Let's do this now. Git status reminds us we are on the auth branch still. With git checkout master, we move head to the master branch. Git updates our working tree and index. Git diff master.sdn shows what will change when we merge SDN into master. The S1 file in the master branch will get that SDN controller line from the SDN branch. From the master branch, we want to merge SDN. Git merge SDN. Git confirms we have done a fast-forward merge. Git has added one line to S1. Cat S1 shows this. With graph, we see the master branch is caught up with the SDN branch now. Git has moved the pointer to the same commit where SDN is. Now we are done with our work on the SDN branch. The work has been merged into master. We don't need the two branches pointing to the same commit, so we can delete the SDN branch now. After that, we will look at a three-way merge. Deleting branches. We see how the master and SDN branches point to the same commit. We integrated our SDN work into master, so we can delete the SDN branch. Before we delete SDN, there is a handy command to check which commits are already merged with the branch we are on. Git branch -- merged. This shows us that our master branch is merged with the SDN branch. Now that we know these branches are merged, we can safely delete the SDN branch. Note how the auth branch is not listed here since we haven't merged it into master yet. Let's delete the SDN branch. Git branch -d SDN. Let's also try deleting the auth branch. Git branch -d auth. This time, Git actually blocks us from deleting the auth branch with a warning. The branch auth is not fully merged. However, Git lets us know that if we really want to, we can still delete the auth branch. To do this, we would use the uppercase D flag instead of the lowercase d. We want to be careful in this case because we would eventually lose work we did on that branch we deleted. That would happen when Git performs garbage cleanup on the commits in the deleted branch. Now that we've merged and deleted the SDN branch, let's do the same for the auth branch. Looking at the commit graph, we see there's not a direct path from the master branch to the auth branch. Git cannot do a fast-forward merge this time. For this case, a three-way merge will happen. Three-way merge. To merge master and auth, we can't just move the master pointer over here. If we did that, we would lose our SDN changes we made over here. We need to merge these branches together into a new commit called a merge commit. To make this merge commit, Git looks at three commits. First, the base commit the two branches started from, then the last commit of each branch. Let's merge auth into master now. Git status shows us we are on master. Git merge auth starts the merge. Since we are making a merge commit, we are going to need a commit message. We can accept Git's default message here, save and exit. The merge is done. The output does not say fast-forward merge like last time. Now it says merge made by the recursive strategy. With graph, we can see the merge commit joining the two branches. Now we can safely delete the auth branch. Git branch -- merged confirms this. We delete the auth branch with git branch -d auth. This three-way merge worked out without any conflicts. However, sometimes there are conflicts when merging branches together. Next, we will see how to resolve a basic merge conflict. Merge conflicts. A merge conflict occurs when we try to merge branches that have changed the same lines in the same files. Let's see an example of this by creating some conflicts in two branches. We will work on a new branch named dev. We can use a one-line shortcut to both create and check out a new branch. Git checkout-b dev. This saves us a little bit of overhead from typing git branch dev and then git checkout dev as separate commands. Now let's make some edits to S1. We will change the red VLAN to green. Also, we can change port 1 to VLAN 10 and port 2 to VLAN 20. I'll save and exit. Git diff shows us our new modifications. Let's get this staged and committed with one command. Git commit -a-m update S1 VLANs. Now let's check out master and make changes to S1 on the master branch. Here we will change the management IP. We will change the red VLAN to pink. We will move port 1's VLAN to VLAN 10. Finally, we will delete port 2. Now we can save and exit. Let's stage and commit this. Git commit -a-m update S1. Graph shows our two branches have diverged, so we know there can't be a fast-forward merge. This is going to be a three-way merge, and there are going to be conflicts. Here is the version of S1 on the base commit. Here is the version of S1 on the master branch, and here it is on the dev branch. On the master branch, we changed the management IP. On the dev branch, we did not change the management IP. Therefore, on the merge, Git will assume we want to change the management IP. With the change versus no change, the change will win. Next, on the dev branch, we changed VLAN red to green. On master, we changed that same VLAN to pink. Since we've changed the same lines in both files, we have a conflict. Git can't guess for us which one we want in our merge commit. Next, we changed port 1 from VLAN 20 to VLAN 10. However, we did the exact same change on both branches, so there will be no conflict there. Finally, port 2. On dev, we changed it from VLAN 10 to VLAN 20. However, on master, we just deleted it. This will be another conflict. Okay, let's try our merge now. Git status shows we are on master. Git merge dev is used to start our merge. This time we get a notice. Merge conflict for S1. Fix and commit the result. Git status looks different than what we usually see. Git indicates we are in the middle of a merge by saying you have unmerged paths. First, we can see Git gives us a backout plan. If we don't want to deal with resolving the conflicts here, we can run git merge -- abort. Assuming we started with a clean working tree and staging area, we can do this. Let's try that now. Running git status shows we are out of the merge process. Graph shows us we are right back where we were before. Let's actually proceed with our merge though. We can run git merge dev again. Now, git status again. Git has modified S1 to mark where we have conflicts. Let's edit S1 and see this. We see the two commit conflicts, the VLAN color here and the deletion of port 2 versus a VLAN change on port 2 here. Let's start with the VLAN conflict. This set of equals signs separates out the state of the files in the two branches. On head, which currently points to master, VLAN red changed to pink. Below the equals signs shows that on the commit the dev branch points to, VLAN red changed to green. We need to decide how we want our merged file to look. When we decide, we delete the git markers, the equals and the brackets, as well as the text we want to drop. Let's go with VLAN green and delete pink. Also, we delete the git markers. Now to the second conflict. On master, we removed port 2 entirely. On dev, we moved the VLAN from 10 to 20. Let's say we want to stick with VLAN 20. We keep that and we delete everything else. Now we've finished our conflict resolution, so we save and exit. Our conflict resolution changes are in the working tree. We stage this as we do for a standard commit. Git add S1. Now git status shows all conflicts are fixed, but you are still merging. When we commit this, Git creates our merge commit. Git commit. The default commit message is acceptable, so we save and exit. Graph shows our merge commit. We can safely delete our dev branch with git branch-d dev. That's it for our look at merging. Now let's look at a state in Git that can look pretty ominous when you're new to Git. However, as we will see, usually it's quite easy to get out of. The detached head state. Usually head points to a branch, which in turn points to a commit. When head is instead pointing directly to a commit, we have the detached head state. Let's try checking out a commit instead of a branch. Git log shows our commit history. Maybe we just want to look around at how our files looked when we were at this snapshot here. Git checkout and then a commit hash. With this command, we are checking out a commit directly by its SHA-1 hash. Now, Git gives us some warnings. Graph shows us the situation. We have the head pointer directly referencing a commit and not a branch. This is a detached head. One way out of this state is to just check out a branch again. Git checkout master. Now we no longer have a detached head. Let's go back to that commit to see another way to handle that detached head state. Git checkout and then the commit hash. We can put a new branch label here. Git branch stage creates the stage branch here. Graph shows we have our new branch, but head isn't attached to it. Git checkout stage checks out our new branch. Graph shows the head pointer is no longer detached. It is attached to our new stage branch. From here, we can proceed normally. Now let's cover our final topic. Up until now, every time we checked out a branch or performed a merge, we had a clean working tree and staging area. We had no modified files and no staged changes that were not committed. Sometimes when we don't have a clean state, we will see an error in Git. We will be blocked from changing branches, or we can complicate merging of branches. An excellent way to quickly get a clean state is the git stash command. Git stash. Let's check out the master branch. We can edit S1. I'll add a yellow VLAN with ID 30. Git status shows our working tree is changed for S1. Now we try to check out the stage branch we made earlier. Git checkout stage. Git actually blocks us from doing this. To check out the stage branch, Git would update our working tree and our staging area. If Git did this, we would lose our recent changes to S1. Git is stopping us from wiping those changes out. Git tells us what we can do here. We can commit our changes, or we can use git stash. Let's do the latter. Git stash. With git stash, Git has saved our new changes to S1 so we can apply them back later. Git status shows we are back to a clean state. Now we can freely check out branches or perform a merge. Let's do another edit and stash that as well. We can remove the auth server. We will run git stash again to save these changes. With git stash list, we see our two stashes. With the -p option, we can observe the edits that occurred with each stash point. We can reapply these stashes at any time. We do that with git stash apply. On its own, git stash apply will reapply the most recent stash. With git diff, we see that removal of the auth server has been restored. Let's commit this change. With git stash list, we see that we still have two stash points. We didn't pop or remove the most recent stash, so we can reuse stashes as needed. If we really wanted to apply the stash point and remove it from the list, we could have used git stash pop instead of git stash apply. If we want to utilize a different stash point other than the most recent one, we can call it out by one of these labels. So for the first stash we made, we can apply it with git stash apply and then the label. Git diff shows that the yellow VLAN is back from the stash point. In the output of git stash list, we may want a better reminder of what each stash contains. We can provide a message with a stash with git stash save and then our message. For example, git stash save add yellow VLAN. Now git stash list shows a more helpful message with the stash point. Okay, that was our last topic for this video. In a moment, we will wrap up with a quick review of everything that we've discussed. Before the final review, a quick plug. Thanks so much for watching this video. If the video benefited you in any way, please support this channel by commenting and subscribing. It really helps to hear back from people watching the videos. If you have a question, feel free to post it. Even if I don't know the answer, often another viewer will. If you want to get in touch with me, feel free to message me on LinkedIn. Final review. This video focused on branching and merging in Git. We started by creating a new repo and made 2 commits. We witnessed how Git automatically creates our first branch in our repo. By default, Git names this first branch the master branch. A branch is a small label that points to a commit. We also saw the head pointer. The head pointer tells us what we have checked out in Git. Usually, head points to a branch and is a symbolic pointer. If we check out a commit by its SHA-1 hash, we get the detached head state. We can get out of the detached head state by checking out a new branch at the commit we are on. Also, we can just check out an existing branch. In our repo, we created 2 new branches with the git branch command. The branches were created based on where our head pointer was located. We saw how checking out a branch means moving the head pointer to point to a branch. We worked on the 2 branches SDN and auth. We saw that when we make a commit, the checked out branch and the head pointer move forward to the new commit. We merged our 2 branches into master. First, we merged the SDN branch. We checked out master and ran git merge SDN. This was a fast forward merge since there was a direct path from master to SDN. In our case, we only had 1 hop, but many hops still would have been a fast forward merge. We saw how to delete branches with git branch -d. This command will only delete merged branches as seen with git branch -- merged. If we wanted to delete branches that are not merged, we could use uppercase D. We performed a 3-way merge to get the auth branch into master. This was a 3-way merge since there was no direct straight line path from auth to master. A 3-way merge looks at the common base commit and the tip of each branch to figure out what the final merge commit should look like. Next, we looked at some basic merge conflicts and how to resolve them. We saw how Git puts markers in files to indicate the lines in conflict. We edited the file with conflicts, removed the Git markups, and committed the change. This resulted in a merge commit, completing our 3-way merge. Finally, we wrapped up with a look at Git stash. Git stash is useful when we have unfinished work that is not committed. We can stash that work for later use. Once we run git stash, our working tree and our staging area are clean. That's it for this video. The next video will cover working with remote repos. Also, it will cover some commands that alter your commit history, rebasing, amending, and cherry picking. Thanks for watching.